Okay, so good evening, everyone. Uh, Welcome to this session. And this is the last second session in this course. And we'll be having one more session next week on Tuesday, probably. So, in today's session, we will try to cover some of the topics that were covered in the week 12 of the course. So, just a second. Yeah. Are you able to see the screen? Okay, great. So we have covered quite a lot of topics so far. So in this session, we will briefly look into the PageRank algorithm, and then we'll see the intuition behind the algorithm and solve it using two approaches in Python. One is using NetworkX library, and other using the traditional way. Uh, we'll see the code. Then we'll move on to Collat's conjecture. We'll see what it is, and then we'll write a basic code for it. And then we'll do a brief recap of Python concepts that we have discussed so far. And in the next session, I'll try to cover some of the uh, like programming questions on the topics that we have covered so far, so that you will get a hands-on on how to do programming in Python and how to approach certain problems using the concepts we have seen so far. Okay, so let us go to the PageRank algorithm. So you might be aware of search engines like Google and uh, Perplexity and so on. So when you search something on Google, for example, let me share my entire screen. If I search Harry Potter, so you'll get some results over here. So you'll see that there are certain results that are on the top compared to the other results over here. So why is it so? And what's the algorithm that runs behind it? Like if I want to search something, how do certain pages get more importance than certain other pages? And by pages, I mean the web pages. So if you visit this entire thing is a single web page and which has a certain URL associated with it. So the moment I give add certain query over here, the Google search engine returns certain, uh, a list of results over here. And what we'll be seeing in this session is the algorithm that is behind this, the kind of result that you get. And this algorithm is known as PageRank algorithm. So the basic intuition behind is let me show you an example. Okay, so let's say there are multiple pages, and then the question is how to decide which page is more important than the other pages, like how to rank these pages. So the first intuition behind it is that if a page is being pointed out by multiple pages, then its importance increases. Okay, so that is one criterion. However, there is an issue with this. So can someone point it out what exactly is the issue over here? So if let's say if there is a given page and it's being pointed out by 100 pages, so what will happen? Just a basic intuition. You can answer in chat. Okay. So let me discuss that. So let's say there are many relevant pages given to a given for a given query, and I create a new web page on my own. And if this were the criterion that if a page if a page is pointed out by multiple other pages, its rank increases. If this is the only criterion, then in that case, I can always create thousand other pages and then point it out to my page relevant to the query. Let's say Harry Potter. That what we saw earlier. So I can create a web page with certain information or certain blog on Harry Potter, and I can create thousand other pages and then just point them out to my blog. By what do I mean by pointing them up? So you can hyperlink a page. For example, this page is having a link to this Wikipedia. So this Google search page is having a link to the Wikipedia page rank algorithm. So this is how a page is linked to another page. So I could have just simply created thousand other pages and then linked it to my own and to increase its rank. But it doesn't work like that. There is another criterion that is taken into account is the importance of the existing pages which are pointing to your page. For example, over here, you can see that this particular page over here, so each node in this particular graph represents a page or a document. So this particular page over here is being pointed out by multiple pages, okay, compared to some other nodes over here. However, you can see that the rank of this particular page is pretty low. Why? Because this is being pointed out by less important pages. However, if you see over here, page C, so this is being pointed out by page B, and because of that, its rank is also higher compared to the other pages. So if you are being pointed out by many other nodes, as well as the important nodes, even if it is not multiple other pages, even if it is very few pages, and if they are important enough, then the rank of your page eventually increases in the search engine results. So that is the basic intuition behind this PageRank algorithm. There is some mathematics involved in it, so we won't be going into the details of the mathematics, but we'll discuss a basic intuition behind it. So let me just show you an example. But before we move on, is this intuition clear, like what exactly PageRank does? Okay, great. Okay. So let's say you have three pages initially, and a page is pointing to another page. Okay. So this particular page is pointing to two other pages. This particular page is pointing to only one page, and this is not pointing to any of the pages. Okay. So initial assumption over here is that the rank of each page is equal. So how many pages are there in total? That is three. So the probability of um, you know getting any page in the search result at the top is 1 by n, which is 1 by 3 over here. Okay. Now, once you get this information, based on the uh, incoming nodes And the importance of each of these pages, you iteratively try to correct or update the ranks of each of these pages. Okay, so this is generally given by a formula. But before that, before we discuss that formula, I want to discuss one particular concept. Okay, so that is the problem of random walk. So let's say you land, you have been given this all these pages over here. Let's say this is a complicated graph. You have page over here, a page over here. So I'm just creating some random edges over here, and these are the directed edges. So uh, by directed, you mean like there is a link from a node A to node B. However, there is no in this case there is no directed link from B to A. Whereas in undirected graph, it would have been considered the same. So you have link from A to B and B to A both, but in this case you only have a link from A to B. Okay. So each of these nodes will be having certain, sorry, each of these edges will be having certain weights associated with them, which is nothing but the probability of visiting a given node from a given node. For example, it might be like point 0.1 over here, like probability of visiting node B from node A is zero point 0.1, and then the other one will be zero point 0.9, and so on. So each of these edges will have certain weight, and that is known as the weighted graph. Initially, we assume that the probability of each, or sorry, the rank of each particular page over here or node over here is equal. That is 1 by the total number of nodes that we have in the um graph or the network. However, we'll have to update it based on the number of connections that a particular node has and how many important other important nodes are pointing to that particular node. Okay, so the one simpler way to do is to just take a random robot. Let's say there is a robot over here, and you randomly move on to some other node over here. Let's say node B, and from node B, let me just give some names to these nodes over here. Node A, B, C, D, E, and F. Okay, so I'm not writing the weights over here on each of these edges, but yeah, we assume that this particular robot can just move on to any of the random nodes in the beginning, and then from there it can take random walks. Okay, so what is random walk? It is like from a given node, you have certain probability of going to any of the paths. So you just keep on moving to any random direction based on the probability. It may move to the higher probability, probability edge or the lower probability edge. It all depends. But if you keep running it for multiple iterations, you will get the total number of visits for each of this particular nodes over here. So let's say this robot visits node B, then from node B, let's say it goes to F. From F, it cannot go anywhere. So that is the dead end. However, we don't want this condition to be there. So we assume that from this particular node, it can also visit any other random node over the complete graph. Also, there might be certain cases where there are certain pages which are not connected to this particular graph, subgraph. So let's say you have pages on Harry Potter, and then you have pages on some other um movie, let's say Lord of the Rings. So if have a query relating to Harry Potter, there might be certain pages which are interlinked together. However, there might be some pages which are not relating to the topic that we are discussing, but they exist in the network and which might be some having some relevance. So we cannot leave them out, okay, totally. So what we do is we introduce a factor called damping factor, D. So which is generally taken as 0.85. So what it shows is, okay, if I am on a certain node, I can visit its neighbor with the probability D, and I can visit any random node in the graph or network with probability 1 minus D, which gives us a flexibility that we can visit any random node in the particular graph. Okay, so in general, the iterative algorithm for page rank can be written as P of. So initially, the page rank of each of this node, P of, let's say node I, where I is A, B, C, D, E, F, G, whatever nodes are there, is equal to 1 by n. Now we want to iteratively correct it. So the page rank in the subsequent iteration, so this T represents the next iteration, can be given as 1 minus D by the number of nodes plus D times, this is P of I, node I, summation of the page rank of all the uh, nodes which are linked to this particular page. For example, B has A linked to it and C linked to it. So whatever pages are linked to B, the page rank of that divided by the total number of outgoing edges from those particular nodes. So for example, initially the page rank of node A was 1 by n, and forget about this node edges over, sorry, the weights over here. So we will, so how many outgoing edges are here for this particular node A? 1 and 2. So if I am on node A, I can either go to node B or node F over here. So I write the total number of outgoing edges from this particular node. So page rank of this particular node divided by the outgoing edge, number of outgoing edges from that particular node A. So this can be written as O of, let's say, J. Okay, so this is pretty messy. Sorry for that. Let me go on to the Wikipedia page and I'll show you this particular formula over there. So here it is. Page rank of a particular node, let's say A, is equal to 1 by D times. 1 by D is the probability of visiting any random node which is not connected to it, into 1 by N is the probability, plus D is the probability of visiting the nodes uh, which is connected to the particular node A, and then the page rank of each of those connected nodes divided by the number of outgoing edges of those particular nodes. Okay, so this is done iteratively over time for a certain number of iterations. And this is how it is represented in general. So PageRank of Pi is 1 minus d times the total number of nodes plus d times, where d is the damping factor that we have seen, summation of all the nodes that are connected to Pi. So M over here is the matrix, adjacency matrix that we discussed in one of the sessions earlier. Uh, I'll wait for some time, like if you have any queries. So we sum over all the nodes which are connected to I. So page rank of node J divided by the number of outgoing node edges for node J. Okay, so this is the algorithm that is there. And there are like linear algebraic way of solving this. So we won't be going into the details of the algorithm now. But this was the basic intuition that we need to understand for updating the page ranks of each of the nodes or pages that are there in the network or graph. So are there any queries relating to this? We will discuss this in collab now. Yeah, please feel free to ask if you're not understanding. Yeah, I'm here to explain. This is not a part of the course. I think this was not discussed. The algorithm was not discussed in the course in detail, but yeah, I just wanted to discuss this so that you get an idea of what's happening internally. So before we jump into the PageRank algorithm, okay, okay, I'll explain it again. Yeah, by the way, don't bother about this. This is not a part of your sorry, course. Like you won't be asked uh, many questions on this, like the algorithm, but there will be very generic questions about what PageRank is and uh, why it is used. So let's say you have a graph. Uh, this graph represents the web pages, and it might be disconnected graph. Okay, so this all these nodes, they are part of one single graph. Okay, and these are some web pages which are interlinked together. And there might be some disconnections over here. Like these might be some web pages on some random topics, some other topics, and then this might be on topic, some other topics. So initially, the assumption is that the page rank of each of the nodes over here is equiprobable. It's equal. So which is equal to 1 by n, where n is the total number of nodes over here. In this case, n is 1, 2, 3, 4, 5, 6, and 7. So 1 by 7 is the initial rank of it. Let's say this is node A, B, C, D, E, F, and G. Okay, so P of A at time, let's say 1 initially. You can write even 0 as well over here. Let us write 0. P of A, page rank of A, we can write PR also over here. Let me just write PR to avoid any confusion. Is 1 by n. Now, we want to compute the page rank of uh, A after doing after taking into account the nodes that are pointing to A or connected to A, and also the other nodes which are not connected to it. Okay. For that, to take the other nodes into consideration, uh, we have this damping factor D, which states that you can visit a node connected to a given node with probability D, and then you can also visit any random node from a given node with probability 1 minus D. Okay. So if you see this formula over here, the page rank of a particular node at time t plus 1 is equal to 1 minus d, which is probability of visiting any random node not connected to this particular node, into the probability of each node 1 by n, plus d is the probability of visiting the node connected to this node I. And let's say you have all such node j's, and j belong to the set of nodes which are connected to node I. So what you are doing over here is you are summing over the ratio page rank of node j divided by the number of outgoing nodes from node j. So for example, over here, let's say node C. So node C is being pointed by A and B. Okay. And what is the initial page rank of A? It is 1 by n. And how many outgoing edges does A have? It is 2. Okay. So 1 by n divided by 2, plus what is the other node that is pointing to C, which is this is B. So initial page rank of B is also 1 by n. And then uh, what is the uh, number of outgoing edges from B? It's only 1. So it is divided by 1, and so on. So that is how this particular algorithm works. So at a given time step t plus 1, you use the page rank at time step t and then compute it accordingly. So is this particular part clear, Master? Okay, great. So before we dive into the Python code for that, let us briefly recap the NetworkX library, and then we'll move on to seeing the NetworkX implementation and the basic Python code implementation for whatever we algorithm that we have discussed for PageRank. So as we have discussed, NetworkX is the library used for creating graphs, and the graphs can be either undirected graph or directed graph. So we have so far seen only undirected graph in the previous sessions. In this session, I'll also discuss the directed graph and the weighted graph, like how to create directed and weighted graphs. So we'll first import networkx as nx. Matplotlib is used for plotting the network, whatever graph that we are creating. Then to create a graph, empty graph, we use nx.graph. This will create an empty graph without any nodes and edges. You can add add a node to the graph using add node option, or you can pass on the list of nodes and then use the function add nodes from, okay, which accepts a list of all the nodes that you want to add to the graph. And then similarly, you have add edge option, in which you can add an edge from a given node to another node. In this case, this is undirected graph, so there won't be any direction as such from 1 to 2 or 2 to 1. It's just the same. And then uh, if you want to pass on the list of tuples having where each tuple represents an edge, so you can use this function add edges from and pass on a list of tuples over here. And let me just quickly run this part. Okay. So we have added five nodes over here, one, two, three, four, five, and we have edges one, two, one, three, which are over here, one, two, one, three, two, four, then three, four, and four, five, three, four, and four, five. Okay. So every time you run, it need not be like this particular shape is going to be there. It might be some other shape as well. So you can see that over here. Earlier you would have seen like the graph was having some other shape, but the connections are just the same. It happens because of some random assignment of the space that happens internally in the network X library. You will have to set some set value over there in order to replicate, like, the get the exact same graph every time you run the code. However, if I run this again, you will see that the shape of this particular graph gets changed, but the information is just the same. Like, there are five nodes and there are edges that we have already declared. Okay, so this was about creating an undirected graph. But now, how to create a directed graph? So for that, there is uh, something called as digraph. Digraph stands for directed graph in Network X. So let me run this again. So over here, we are creating an empty directed graph. We are adding three nodes to it. And then the moment you add an edge to the directed graph, it means that there is an edge from the starting node to the ending node, means with a direction from 1 to 2, okay? Or starting node to ending node in general. Similarly, you can use add edges from to the directed graph. However, like in the case of undirected graph, those were simple edges without any direction. Here, there will be a direction associated with every edge. So over here, we have the edges 1 to 2, 2 to 3, and 3 to 1. So you can see over here 1 to 2, 2 to 3, and 3 to 1. So this is a cyclic graph that we have created over here. Okay. So this was about directed graph. Very, very similar to undirected graph. The only difference is that there are directions associated with it. Now there is one more element that is associated with the graph agents, which is the weight. And these graphs are called as weighted graph. So let me run this particular part over here. So what we are doing over here, we are creating an undirected graph. It can be directed graph as well. It doesn't matter. It can be weighted directed or weighted undirected graph. Then we are adding nodes over here. As we discussed, the nodes can be anything. It can be numbers or strings or any functions and so on. It can be even another graph. Okay, so that doesn't matter. So in this case, we are considering A, B, C, D as the nodes. And then we are adding age from a given node to another node with a particular weight over here. So there is this weight parameter in the add age function, and then we are printing the graph. So you can see over here from A to B, we have an age with weight 3, A to B, age with 3, A to C we have weight 2, B to C we have weight 1, and C to D we have weight 4. Okay. So this was about creating undirected graph, directed graph, and weighted graph. Is it clear so far, everyone? Okay, great. And let me discuss some other kinds of graphs that you can generate in NetworkX, and we'll move on to the uh, algorithm, PageRank algorithm. Okay, so uh, in your course, in this week's quiz, you might be seeing some questions on different types of graphs that are out there. So let me quickly run this. So there are multiple different types of graphs that we're generating in this particular code. Okay, is there any query? Yeah, please be on mute if you don't have any queries. And please feel free to ask me any questions you may have. Okay, so these are different kinds of graph. We'll just quickly discuss this. So we have a breach graph. So in a breach graph, you have only two nodes over here, and there is a connection between these two nodes. So that is the simplest definition of this breach graph. Then we have a complete graph. A complete graph is a graph in which every node is connected to every other node. For example, this particular node is connected to all the other three nodes over here. Okay. And then we also saw there is another category of graph called connected graph. A connected graph may not be a complete graph, but a complete graph is known as fully connected graph. So in a connected graph, you may not have like no, every edge connected to every node connected to every other node. However, there might be some path, indirect path, uh, even if there is no edge between, let's say, this particular node, two nodes. However, you can reach this node through some other path. Okay, so that is the in that case the graph is known as connected graph. However, if there is an edge over here, so in this case it becomes a fully connected, and that fully connected graph is known as complete graph. Then we have a star graph in which you have a central node and which is connected to all other nodes. Okay, then we have a cycle graph. Now you might be wondering like where on earth the cycle is coming into picture over here. So if you see, you can go from 0 to 5, 4, 3 to 1 and back to 0. This is the undirected graph. It can be directed graph as well. Although you see a crossing over here, so this is not a node, by the way. It could have been like, as I said, network X generates random shape of the graph every time you run it. So let me just quickly run it once again. Okay. So in this case, you're only seeing some other orientation of the graph. It could have been like this 5 would have been over here, so you would have seen a clear cycle. But this is also a cyclic graph. So please don't get confused that there is a crossing over here. It doesn't matter. It's just a cycle just bended over. Okay. Then you have a path graph in which like uh you'll see a linked list sort of a structure in which there is only one edge between, so it's like a straight line and all the nodes are in the straight line and there is no other edge from any other node. Okay. Then we have a ladder graph. Again, it is like in the shape of ladder. Uh, there's not much explanation needed for this. Then we have a barbell graph. So barbell graph is a special graph in which you have two fully connected nodes, sorry, graphs connected by a path over here. So in this case, 0, 1, 2, 3, these nodes are fully connected. 6, 7, 8, 9 are fully connected. And these are connected by a path over here. It can be any number of nodes over here. Okay. So this particular kind of type of graph is known as barbell graph. And then you have a wheel graph. Again, it doesn't look like a wheel, but if you can just see the star graph over here and connect each of these edges over here, like 1, 4, 2, 5, 3, 1, that becomes a wheel graph in the shape of a wheel. Okay, so these are some terminologies or some names associated with different types of graphs. You might be getting some questions on what is a wheel graph or what kind of graph this particular graph is and so on. And you'll be given some options over there. So yeah, you can just keep these uh, things in mind. And these are pretty simple just for the demonstration of the use of network X. So how we are doing it in network X, by the way. So in network X, there are these inbuilt functions to generate this particular kind of graphs. For example, over here, uh, to create a complete graph, you can use nx.complete graph with the number of nodes that you want to have. Similarly, for star graph, you have the star graph function. For cycle graph, you have a cycle graph function with the number of nodes in it. Then there is a function for path graphs, ladder graph, and so on. So there are these functions inbuilt in the NetworkX library. I'm not sure if all these functions were used in the demonstration that the TAs did in the lecture videos, but yeah, you can definitely remember this. So these are pretty simple to remember. So this is just the graph name with underscore over here. Okay. So any queries so far? Is it clear? Okay, thank you. So what we have seen so far is the basic intuition behind the PageRank algorithm. We did a uh, brief recap of NetworkX. We saw how to create undirected graph, the directed graph, and weighted graphs in NetworkX. And we saw different types of graphs that are out there and how you can create them using NetworkX library. You can look into the details later. I'll share this Python notebook, collab notebook with you in the shared folder, drive folder. So you can definitely play around with this. You can just make a copy of it. So you just have to go to file and then save a copy, select save a copy in drive, and you'll be able to, run the code in your system. Okay, so this was all about the NetworkX library. Then how it can be applied for PageRank. We'll come to that. But before we use NetworkX, let us see the simple NumPy implementation of the uh, PageRank algorithm. It is a bit complex, so we are just simply trying to code this particular part over here, like the iterative version of the PageRank computation that we discussed. Okay, so what we are doing over here? So we have an adjacency matrix. So we have discussed this in the previous session, but just for the sake of those who did not attend the session, uh, any graph can be represented using two representations. One is called as adjacency matrix, and the other one is called adjacency list. Let me quickly show it to you. Okay, this is a good example. So here I have a graph, and then it has five nodes. So each of these entries over here in this array represents a node, and each array points out to a list. So in computer science, there is a data structure called list, in which a node is attached to other node, and each node is having a value and a pointer to other node. Okay. So in this case, one is connected to two, okay, and it's also connected to four. So one is connected to two and four, two is connected to one, four, three, three is connected to two and five, four is connected to two and five, and five is connected to four and three. So that's how this linked list, so this particular representation of the graph is known as linked list representation.
Still not visible.
Oops, sorry, sorry. Thank you for pointing that out. My bad. Yeah. So what I was showing over here is like there is a graph over here and it has five nodes and you have an array which contains each of these nodes. And for each of these nodes, you have a list associated over here. And in computer science, a list is a data structure in which you have nodes, and then each node has a value and a pointer to another node. Okay. And if there is no other node to be pointed, so then that particular pointer points to null. For example, here slash means null. So one is connected to two and four over here. So you can see that there is a list attached to one having two elements, two and four. Then, where by the way, this does not mean that two is connected to four. Means it necessarily doesn't mean that two is connected to five. For example, over here, four is connected to two, three, five. Sorry, one, two, and five. So you can see one, two, and five over here, but two and five are not connected as such. So this doesn't mean that 2 is connected to 5. It just means that 4 has 1, 2, 5 as the connection. Okay, so this is known as the linked list representation, adjacency list representation for a given graph. Similarly, a graph can be represented using a matrix in which the so this matrix is the number of nodes cross number of nodes matrix. So here there are five nodes, so it is 5 cross 5 matrix. And then if there is an edge between any two pair of nodes, in that case, the entry in the matrix will be 1, otherwise 0. Okay. Assuming it is a uh, undirected graph. Okay. So this just represents there is an edge over here. However, if there is a weight associated with these edges. So you can also have weight over here. Like 1 to 2, there is a connection. So there is 1. 1 to 4, there is a connection. That's why there is 1. 1 to 5, there is no connection. Hence, it is 0 over here, and so on. However, if there is any weight associated with these edges, so instead of writing 1 over here, you can also write the edge weight in that case. Okay. So that was about the adjacency list representation and adjacency matrix representation. So coming back to the Python code. Okay. So here we have three nodes, A, B, C, let's say, and A is connected to B and C, B is connected to A, and C is connected to. So this is like a directed graph, and C is connected to C over here. Like there is a cyclic loop over there. So what we are doing first of all, we are getting the total number of pages, which is nothing but the length of this adjacency matrix. Then we are defining a damping factor D that we discussed here. So D is the damping factor. Then initially the page rank is uh, equal for all the pages, which means that it is 1 by n. So what this particular thing does, np.once, okay, let me just run this quickly. So we are importing numpy and np.once of, let's say, like 3. So this will give me an array of ones for a given input size. If I say, let's say 10, so it will create an array with all ones over here, each being a floating point value, like 1 point. You can see 1 point over here. So 1 point means 1.0. So it is an array of ones, so, of given size. So what you are doing over here? So there are three nodes in this. So I am creating array of 3, and if I divide it by 3, so it will create 1 by 3, 1 by 3, 1 by array, 1 by array having 1 by 3, 1 by 3, 1 by 3 as the elements. Okay, so each ones over there is divided by 3. So we are having this page rank vector in which you have np.ones divided by the total number of pages, and it shows the probability of each page. Then we are defining the number of iterations for the page rank calculation. So what is an iteration over here? So this is like first iteration in which you are sorry, let's say second iteration in which you are using the value of first iteration. If it were third iteration, you are using the page rank in the second iteration, computed in the second iteration, and so on. Okay. And then now we are writing the page rank algorithm. So this particular part uh, mimics this particular algorithm over here, or this particular formula over here. So let us see it step by step how it works. So first of all, we are running given number of iteration. So this loop is being run for given number of iteration, and you will see some strange thing over here. So generally we write for I in range, something for j in range. In this case, in case of Python, you can also write underscore. So if you don't want to add any name over here, you can simply write underscore, which acts as a placeholder. So you need not write if for I or for num in range or for iter in range, num iterations and so on. Simply write underscore, and this will run as it would have run for any variable name over here. Okay. So what we are doing, so we have a page rank vector which contains equal probability for all the nodes. We are creating a copy of it and assigning it to a new page rank, which needs to be updated. Okay. We don't want to touch the actual page rank vector because we want to update all the nodes based on the existing, values. So to avoid updating those values, we are just copying them to a new page rank vector, and then we go on to each of the nodes in that. So for I in range, this will iterate over each of the nodes. First of all, we see what all links are having incoming edges to a given node. And for that, we are using this np.where. So let us see what this does. Let me run this particular part, and I'll take this particular function and p.where adjacency matrix. Let's say I give column 1. Okay, so this particular function gives us the number of incoming node, sorry, the list of incoming links to a given node I. And what we are doing over here is for each of the incoming nodes over here. So let's say for node I, you are seeing all the incoming nodes j. So that is being given by the function where once you get the list of that incoming nodes, you are finding out the sum of ranks, which is this particular part over here. Sorry. So you're finding the sum of rank, which is page rank of node J divided by np dot sum adjacency matrix J. So this np dot sum adjacency matrix J will give you the total number of outgoing edges from the node J. Okay. So you're doing page rank of J and divided by the number of outgoing edges for J, and you're summing it over all the nodes that have incoming edges to node I. Okay. So this particular part is computing the sum of ranks. Now you have a damping factor defined over here, which is 0.85. So the new page rank for node I is 1 minus d divided by n, as we have over here, 1 minus d divided by n plus d times the sum of ranks. Okay, and sum of ranks we have computed over here, which is this. And this we are doing for all the nodes. Okay, for I in range n. So we are computing new page rank for each node. Once we have computed that, we assign this new page rank to the page rank. Okay. So is this particular part clear to everyone? Okay. Not able to see the screen. Was that clear, Masan? Deepika? Okay. Yeah, if it is not, I'll explain it again. I'll quickly once again glance through it. So we are going for a given number of iteration. We are just creating a copy of the page rank. And for each of the nodes, we are first seeing what are the incoming nodes to that particular node. And then using those incoming nodes, we are first of all computing the sum of ranks. And sum of ranks is nothing but the page rank of the incoming nodes divided by the total number of outgoing edges from those particular nodes, which is this particular part over here. So this is the sum of ranks, this entire summation over here. Once you have the sum of ranks computed, now this part is constant actually. 1 minus d by capital N, it doesn't depend on anything. So it is constant. So you are computing the new page rank for a node I as 1 minus d by N plus d times the sum of ranks. Okay. And then you are assigning this new page rank to page rank. So the page rank is updated. Now this keeps on repeating for the given number of iterations. In this case, the number of iterations is 20. Okay. So 20 should be sufficient enough, to converge this. So it will converge at certain point, and there is some linear algebraic explanation to it, which I'll not go into the details of because that might only uh, lead to confusions. So it is not needed for you to understand that. But yeah, this was the basic approach that we follow for computing the page rank. That takes into account the importance of the nodes pointing to the given node and also the number of nodes pointing to the given node. Okay. And then once you have computed all this page rank, you're just simply normalizing it. By normalizing, it means that you're just simply dividing the page rank by the sum of all the values in that matrix so that the sum of every row and column is like 1. Okay, so let me just quickly run this. So initially, we had the probability of each node as 0.33, 0.33, 0.33. And after running this for 20 iterations, you can see that page rank of page 1 is 0.14, of 2 is 0.11, and of 3 is 0.74. Why? You can uh, try running this iteratively, like just try it on paper uh, whenever you have time and see how it, changes the value. You can even do this printing over here. So if you want to see how the values are changing, so how the sums of ranks are changing and so on, you can also print the values over here and play around with this particular code to see how the values changing. Okay. So this was using NumPy array, purely using NumPy array. However, you can also use NetworkX library to simulate the same thing, like to run the similar algorithm. So let us see that out over here. So here we are importing NetworkX as NX. We have the same adjacency matrix and we are creating a detected graph from the adjacency matrix over here. And then there is a simple algorithm in this, function in this called PageRank. So NX is the NetworkX library. It has a PageRank function in which you just need to pass on the graph and then the alpha value. Alpha is nothing but the damping factor D that we have used earlier. It is used generally as 0.85 because it was shown to be uh, optimal. But you can definitely try out different, alpha values or damping factor values over here and see how it works. Okay. So let me just quickly run this code over here. And rest of it is like for the printing purposes. So you can see you have a page rank of this 1, 0, and 2. 2 is being pointed out by 0 as well as itself. 1 is not being pointed out by anything, and 0 is being pointed out by 1. So you can see that 2 is having the highest page rank, followed by 0, and then by 1. So this is like a visual representation of the same thing using NetworkX library. And it's a simple one line function in which you are passing the graph and the alpha value or the damping factor value. So is this part clear to everyone? Okay, great. So these are the two ways in which you can, write the basic PageRank algorithm code. Now moving on to the next part, which is Collard's conjecture. So what is Collard's conjecture? So it is a simple conjecture. Let me just put that up on screen. Okay. So f of n, where f is the Collard's conjecture function, is defined as if n is even number, you make you divide it by 2. If n is an odd number, you take 3n plus 1. Okay. Till the time you uh, end up getting 1 at the end. Okay. So for example, let's say I have, let me clear this. N equal to, let's say 3. So 3 is an odd number. So uh, what I will do, I'll do 3 into, so if it is odd, it is 3 into n plus 1. Okay, so it will be 3 into 3 plus 1, which is 10. Now this is even, so I'll divide it by 2. It will become 5. Now it is again odd, so I'll do 3 into 5 plus 1, which is 16. Now it is even, so I'll divide it by 2. 8, again divide by 2, 4, divided by 2, 2, and divided by 1, 1, and we converge. So, what is the property of this particular 3n plus 1 characteristic or formula over here? So, if you see that no matter what number you start from, every time you will be ending up having this 4 to 1 loop. Okay. So, now since 1 is odd, so it will be 2 into 1, sorry, 3 into 1 plus 1, which is 4. So you will be having this loop over here again. So no matter what value of n you try out, you will definitely converge to 4 to 1 loop. Okay. And let us see it over here. So this is the tree-like structure for Collard's conjecture for different values. So you can see over here, there are different numbers. And for each of these numbers, if you keep on applying this formula, uh, that if n is even, then divide it by 2, and if it is odd, then just multiply it by 3 plus 1. So no matter what you do, you will end up getting this 4 to 1 loop. Okay. So this is the basic Collard's conjecture uh, that is defined. And what our task over here is to write the Python code for it. So it's a simple code actually. Sorry. So what we want to do, given a number n, we want to print out the sequence, the complete sequence of the Collard's conjecture, okay, or Collard sequence. So what we are doing over here, first of all, we are uh, creating a sequence. So while n is not equal to 1, if n is uh, a multiple of 2, then we are dividing it. So this is the floor division, okay. So if n is even, divide it by 2, else n equal to 3 into n plus 1. Okay. So multiply it by 3 and add 1 to it. And then you are just simply appending this n to the sequence. So in the sequence, initially you just have this one. So this is a list that you are creating in which you have the original number. And then you subsequently keep on adding the other numbers as you till the time you don't get one. Okay. The moment you get one, this will be added to uh, so you'll be ending up getting one over here as you get 2 in certain iteration. So 2 divided by 2 will be 1 and 1 will be appended over here. And then the moment you go back over here, you will be stopped. And then you are returning the sequence. Okay. So let me just run this over here. I'm getting input from the user. So let me just enter 3 that we have seen just now. So you can see 3, 10, 5, 16, 8, 4, 2, 1. You can have any number over here. Let's say 1024. Oops. Yeah, 1024, 512, 256. So this is since this is a multiple of 2, so it just keeps on getting halved. However, let me just run some other odd number. Let's say 13. So it's 13, 40, 20, 10, 5, 3, and again coming back to 4, 2, 1. So is this particular part clear to everyone? Okay, great. So let us go back to seeing some questions and we'll do a brief recap of some of the concepts that we have seen so far in Python. It will be a very basic recap. I just wanted to do it now because in the next class, the last class, we will be seeing some programming questions wherein we'll try to use all these concepts there. So I would like you to go over all these, topics that we have discussed so far. and then we'll see some problems in the next session, which is going to be the last session. And if you have any queries, please feel free to ask me. Like if you want me to discuss any specific topic, please let me know. I'll prepare some material on that and then we'll discuss that on Tuesday next week, mostly. Yeah, please keep checking the email. You will get an email regarding the last session. So, yeah, here are the questions. What is the PageRank algorithm used for? Okay. There are not many questions actually. So, yeah. So the answer is web page ranking. Which of the following factors does PageRank consider in ranking web pages? Okay, many of you got it right. A simple analogy I can give over here is that let's say you are applying for a job and you have your friends in the company. So your friends might give you a referral and that will increase the chances of you getting that particular job. However, if you already know if there is any senior person in the company, let's say manager, and manager knows about you, like your skills and your skill set and everything. So if the manager gives you referral, that will add more importance. It's like it's the same thing. So if you have three or more friends in the company giving you a referral, that will definitely add to your value. However, if the manager uh, gives you the referral, that will be more important than all the friends referral collected together. So that's the basic intuition behind PageRank. So you take into account the inbound link quality, that is the importance of the pages pointing to you, and the quantity, the number of pages that are pointing to you. Okay. So in the context of PageRank, what is a damping factor? Okay. Most of you got it right. So yeah, as I mentioned, so there might be cases that the certain pages may not be very relevant. So we just saw it as a random walk problem, and wherein a robot was just randomly moving on to any nodes. And then there are chances that you may end up clicking or visiting any random node which are not so relevant to the topic that you have searched for. So just to take that into account, there is this concept of damping factor which is introduced. Okay, the factor that represents the likelihood of a user clicking on a link. In the Collat's conjecture, for a positive integer n, if n is even, what is the operation applied to n? Yeah, we just saw this now. Yeah, so that is a straightforward answer. What is the ultimate goal of the Collat's conjecture? This is also straightforward. Okay, so the correct answer is to reach number one, and yeah, that's it. So these are some references that you can look into. So I put the links over here for PageRank algorithm and for Collard's conjecture. So these are some nice videos that will give you an idea of the intuition behind the PageRank and Collard's conjecture. And definitely you can visit W3 schools for, you know, um, looking into the syntax. And let us quickly go on to Collab Notebook, wherein will just do a brief overview of all the concepts that we have discussed so far in Python, and we'll be solving some sorry, programming questions in the next class. Okay. So what we have discussed so far. So Python, we have discussed Python is a high-level programming language, and then it is a interpreted language, unlike C, C++, which are compiled language, in which you will have to compile the code first, generate an executable, and then using the executable you'll run the code. Okay. However, in Python it's an interpreted programming language wherein every statement, so the statements are run line by line. Okay. So even if there is some issue later, it will be thrown during the runtime, and not, you don't have to compile the code and run it. Okay. So that's the difference between interpreted language and the compiled language. So we saw some basic operations like printing in Python, then declaring variables. So there are certain rules for declaring the variables, like what all names you can give to the variables. So it should be alphanumeric in nature. It should not start with numbers. It can start with underscore. You cannot have a special characters in the variable name, and so on. Then a variable can have uh, different data types, for example, integer, float, string, and boolean. You can perform basic operations on the variables like assignment, addition, subtraction, multiplication, division, modulo, or remainder operation, and so on. Then for each of this, so this was on the numerical values. For the strings, you can do string concatenation, you can do splicing, you can find the length of the string, you can convert the string to upper, lower case, you can format the string. I'm just going over the concepts, so just don't be overwhelmed. These are just for the recap. I'll share this notebook with you so you can look into it. So this will be just an overview of whatever we have discussed so far. But there are more details associated with each of these. So I'll urge you guys to go back to W3 School or any other resources online and look into the details. So we also discuss lists, in which we have a collection of objects, and then you can do operations like appending. You can also do some assignments. So lists are mutable in nature, so you can also change certain elements in the list and so on. Then we also saw tuples, which are immutable, which are very similar to lists. The only difference is they are immutable, and also they are like accessing tuple elements is faster than lists, which is due to some internal mechanism. Then we saw dictionaries, which is another data type in which you have a key value pair. Keys can be anything like string, number, or anything. Similarly, values can be anything. You can have even list as value or tuple as keys and so on. We discussed everything in detail in the previous sessions. You can, uh, you know, access the dictionary element using the key string or the key whatever number you have over there as a key over here. Then uh, after dictionary, there was this data structure called sets, which is declared similar to dictionary, but instead of having key value pair, you have just the values over here. Uh, and as we saw in the one of the previous sessions, that the set data structure only contains unique elements. So even if you write a same element multiple times, it will be removed. So only one instance of every element is taken into consideration. Okay. Then you can do set operations that similar to the list, tuple, and dictionary, that you can find the length of the set, you can add something to set, you can remove something from the set, and so on. Then we saw the control structures in Python, uh, like the conditional statements. So if, elif, and else. So if certain condition is true, you execute that particular block. Else if uh, if some other condition is true, you execute that particular block. Else if none of these conditions are true, then you move on to executing something else. Okay. Then we had two types of loops in Python. One was for loop and the other one was while loop. Each of them had their own syntax. So for loop had an iterable over which I used to iterate and then do certain operation. Whereas in while loop, you had a stopping condition. Until the stopping condition is met, you can do certain operations. So that's the only difference between for and while. And you can definitely write a like whatever you can do with the for loop can also be done with the while loop and the other way around. Then we had a least comprehensions, like a comprehensive, sorry, way of writing very complex code in a line. So over here we are like for x in range 10, if x modulo 2 is 0, then you add x to the list. So this particular thing is going to create a list of all even numbers in range 0 to 9. Okay. So uh, you can also write this as for x in range 10. I'll quickly do this over here. For x in range 10, sorry, for that I'll have to declare this empty list, even numbers. If x modulo 2 is 0, even numbers dot append x. So this same thing can be written in one line as this. So x for x in range 10, if x modulo 2 is 0, add that x over here. Okay. So then after that we saw functions. You can define your own functions in Python. You can give any name to the function and then pass on the parameters. Like you can add your own parameters. You can name, last name, and so on. You can also have a default value over here for something, uh, for some of the parameters that you're passing to the function. Even if you don't pass that value, the default one will be taken into account. Okay. And we also saw that the defaults one should be towards the end and not in the beginning. And then you can call out the function using the function name and then pass on some values over here. And then, okay, let me just write this. So you can play around with this notebook later. I'm just going over it now. You can have multiple parameters, and then you can do certain operations and on them and then return that. Okay, this is something that we did not discuss earlier. I didn't want to because it would have confused you. But lambda functions are something similar to functions that we define over here, but these are called anonymous functions. These are actually used for some simple operations. So, for example, over here, lambda x. Let me just keep this particular part. I don't want to discuss and confuse you guys, but I'll urge you guys to look into it. Like if you are interested, you can definitely look into it in detail. Owing to the time constraint, I'm skipping this particular thing. But yeah, this is just for your information that there are something called as lambda functions, which are not actually like defined as functions over here. These are compressed way of writing functions. So for every given x, you can have x square. So if you just call this square as similar to what you call a given function and pass on the value x. So like if you do square and then pass on 2, this will return the x square. Okay. So these are just simple way of writing Functions, you're not giving any name as such to the function. You're just assigning it to a variable and using that variable as the function. Okay. Sorry. Then we had exception handling, uh, in which we had a try except block. So this was just to take care of the errors that you might get during while running your code. So let's say like there is this division by zero error that is occurring over here. So we, there are certain predefined exceptions in Python which you can do. Even if you don't write this, you can just simply write try and except, and it will print it out over here. However, you can write like accept multiple types of errors as well. If it is one of the errors, it will go to that particular block and print that this is the particular error that has occurred, and you need to go and correct your code. Okay, and this also helps you, uh, keep the code running. So even if so let's say there is another part of the code that you have which is not dependent on this particular part, and you don't want this to affect the other part of the code. Okay, so that's why you write this in try catch block, try except block, to take care of uh, you know randomly stopping the code from getting executed, like preventing the random stoppage of the code. Then you had modules and libraries. You have some inbuilt modules or libraries in Python which can be used for doing certain operations. Like for example, there is this math library which can be used for doing some mathematical operations like finding square root and so on. We have NumPy library which can also be used for the similar tasks and so on. Okay, so this was all about the basics of Python that we have discussed so far, and then going into the details of every single thing. Let me just skip this for the time being, but I'll urge you all to look into this. So we have seen Python lists, tuples, dictionaries, and I have examples given for everything. So there are comments also written over here. So like len is used for to get the number of key value pairs in dictionary, and then if you want to access certain keys and values separately, you can use that. So everything is given over here in this. So I have just created this so that it is easy for you to, you know, glance through all the concepts that we have covered so far. So please look into this particular notebook and we'll discuss some programs relating to all these topics. So you have Python sets, Python booleans, then certain operations that you can do on the boolean data type, then Python control structure like if, else, else if, and within loop you can have uh, the controls like the if else statements and so on. Then continue, break, and there is something called as pass, which I think I have not included over here, but there is something called as pass. You can look into it. I'll just write it as a comment. Okay. And then exception handling, we have already seen this. Then Python functions, you can write your own functions, create your own functions, write the default parameters, and you know, expand the output of the given function. So, like for example, it is written in two values, Alice and 30, and then you can assign it to two different variables directly by calling the function. And you have a lambda function over here, and so on. Then you have Python strings. You can perform several other operations on the string, like converting them to upper string, uppercase, lowercase, then formatting the string, finding a substring in a string, and so on. To check if a string is alphanumeric or just alphabetical or is contains only digits. And then you can have a multi-line string and so on. And then we have NumPy library in which you can do some numerical operations on vectors in sorry numerical operations on data like in linear algebraic operations. So yeah, there are some examples given over here, but we have discussed it in more detail in the dedicated sessions earlier. So you can look into those sessions as well, but you need not look into all the videos. You can definitely Just glance through this and go to W3 schools if you have any queries or any other online sources that are available. Then we have pandas library, which we can use to create data frames, and then you can perform certain operations on the data frame. Data frame can be created using dictionaries as well as CSV files. So you can have your data in the CSV file and you can read it as a data frame using pd.readcsv. And then we saw certain operations like you can do some sort of SQL queries like SQL queries or the database queries that you run in general. You can also do that in pandas data frame. So for example, getting the entries of people whose age is greater than 30 and so on, or getting the average number of people, sorry, average height of people in a given city, so and so on. So you can do all sorts of operations using tabular operations using this Python data frame pandas library. Sorry. Then matplotlib is a library plotting uh, for plotting purposes. There are other libraries also. You can look into them. One of them is called Seaborn. Yeah, you can check that out later. I just add it over here as a comment. I think that's the spelling. Let me just confirm it. Yeah, that's the spelling. Seaborn. Yeah. So you can look into this library as well. I just quickly run this, so you can create all sorts of graphs and plots in, you know, Python using this matplotlib library. Then you have a random library which you can use to generate random numbers and then choose some random values from the given list and so on. And then you have statistics library, which we have not discussed in detail so much, but it can be used to, get the compute the measures of central tendencies like mean, median, and mode. And then you can compute variance, standard deviation, and do all sorts of other statistical analysis. Uh, And then we also saw file handling, in which you can read a file in write mode, read mode, append mode. You can write something to the file. You can just read something from the file and then edit it later in write mode. You can, if you open it in write mode, it will just simply overwrite the file. However, if you open it in append mode, it will retain the content of the file and then just simply extend it or like attach the text to the file or append the text to the file. Okay, then yeah, you can check if the file exists or not. So there is a library called OS in which you can do operating system operations. So for example, like to check if a file exists or not, to delete a file, to create a file, you can use this OS library, which is inbuilt, which is there in Python by default. Then we looked into an NLTK library for natural language processing tasks. And there were certain other applications that we saw, like the stylometry analysis, in which you were extracting some features from the text to identify if a given text belongs to a particular author or not. And then we had this pillow library, which was used for dealing with image related data. You can do image formatting, you can resize them, crop them, and change the color, apply some filters, blur them, and so on. Then today we discuss NetworkX, like part of it, but we discuss it in detail earlier. And you can create graphs in NetworkX. You can do some analysis, like social media network analysis, and so on. And there are multiple other things that we would have discussed throughout these past 11 weeks, uh, which I might have missed over here, but I've just given the link to the W3 schools over here, for example, the Selenium library, the Turtle library, and so on. I have not included them over here, but you can definitely look into the details in those subsequent, like in those particular weeks materials. But this was just to give you a primer on, whatever we have covered so far. So yeah, I hope this particular uh, notebook helps you out. And are there any queries? Function topic with regard to return keyword. Can I avoid getting slash n in the output while returning the output value? Had this problem in programming assignment. Can you give me an example, Deepika, like what exactly you are trying to return? So let's say, uh,
Yes, hello. Yes, can you
yeah,
hear
yeah,
me?
yeah, I can hear you.
So in in many programming assignments these days we have to return, they are giving us function
Mm-hmm.
definitions and we need to return some value, right?
Uh-huh.
So when I'm returning,
Uh-huh.
actually it's not a big error because it's saying it's a presentation error. So
Okay.
my outputs are being accepted. But I
Okay.
was wondering how should I remove slash n? Like after my output, there's always a number line. So it's giving me presentation error. So how
I
should I
see.
get rid of it?
I see.
Yeah.
Okay. So
So
let us
I
like
tried using
yeah,
end is equal to double quotes in with the return function, but that was giving me an error. So
I see. Okay. So let us just define our own function. Let's say some dummy function and which returns a string. Okay. And then I'm just calling this dummy and assigning it to A, sorry, and B and C is something A plus B and print C. Okay. So in this case, there is no slash n that is coming into picture. But if the function is defined that way, like if they have slash n defined over there, if it is like explicitly being added, so in that case, you might uh, get that. So over here, if you see, I've added slash n explicitly over here. That's why I'm getting this slash n as well in this return statement. So it all depends on the way the function is defined. So by default, it doesn't add slash in. So we'll have to look into the functions that you are talking about. But yeah, definitely we can discuss it. You please share that particular code. So in the next session, we'll discuss the programming questions. So we can discuss that particular program as well. So please let me know like what assignment it was in, and I'll look into it.
okay, thank you.
Yeah. But yeah, as somebody mentioned, yeah, Leela, I think mentioned, yeah. So if there are print statements in this, so like as rightly pointed out, if there are some print statements in this, hey there, and so on. So every time you write a print, it will by default add a slash in to the statements over here. So to avoid that, you will have to do n equal to nothing. So for example, over here. If I were not to add this, then by default it is adding a new line character. So you'll have to also take care of such instances, like if some things are like if you are trying to print something in the function without this end parameter being set to something, let's say space or nothing. So by default slash n will be added to it. Then But yeah, definitely we'll discuss it in next session. Like if you can give me certain example which you are trying out and then in which you are not able to get the slash and removed. So please, yeah, please let me know.
How can I share the code? Like, should I send a
You can
screenshot?
let me know the assignment number. I'll look into it.
Okay. I had the problem in the recent assignments also, the ones I submitted.
Sir, actually, I had this problem,
Mhm.
but what I did is while returning, I return only the output, and only when I'm printing there outside the function, I gave this equal end equal to double slash. That presentation error went gone for me.
I see. What example was it, Leela? Can you just tell me,
Sir,
like,
for
so
all
that we can?
programming assignments, sir, for
Mhm.
all programming assignments, the same thing, sir. When we are not giving that end equal to double slash, it's showing presentation error for every programming assignments.
I
But
see.
while
I see.
returning, we should not do that end comma. We should, while returning, we should give only the answer. When
Okay.
printing the answer outside the function, if we are mentioning that end is equal to double quotes, the presentation error will be going.
Okay.
So I tried this for everything. Presentation error went for me.
I see. Okay. Yeah, but yeah, definitely. Like, please let me know what exactly so that I can discuss it with others
Okay.
as well. So yeah. So yeah, Deepika, please try that out and also let me know like which particular program, one particular example that you want me to discuss. I'll discuss it in the next class, which is going to be the last class. So yeah, whatever queries you have, please let me know now. I'll prepare some material for that, and then we'll discuss all those problems in the next session. So please feel free to ask any queries you may have. This is your last chance. Yeah. So is there any specific topic you want me to discuss in the next session, or programming questions on certain topics? Yeah, please add them in comments or unmute yourself and ask. Or if you have any queries, any other queries, yeah, you may ask that as well.
So let us note that and come for the next class, sir, from the beginning.
Sorry.
So from the beginning, let us note that what are all the doubts we got and let us ask in next class.
Yeah, so next class is going to be the last class, Leela. So just wanted to know, like what are the topics I am supposed to cover so that I can prepare some material and share with everyone. So yeah, even if you have any queries, you can let me know like now itself so that I'll just note them down and prepare something. Yeah. So I'll wait for some 5 more minutes. If you have any queries, yeah, please let me know in the comments or else we'll conclude. So yeah, thank you everyone for joining. I'll be here for some time, so please let me know whatever queries you may have. Thank you for joining. I submit programming assignment. It is shown error. I see. Pranshu, can you again like point me out to that particular programming assignment? We'll discuss that in next session. Week 11. Okay, great. So I've noted it down. I'll go through the week 11 programming assignments and yeah, we'll discuss that. Regarding Masan, so quiz 12, I think it is not graded yet. So the solutions are not released yet. So I can't discuss it now. But yeah, definitely next week. Um, oh, it will again be Tuesday. But yeah, I'll try to cover that concept. Like if there is any issue with the concept that is not clear, I'll just try to cover that up. But I can't discuss the answer solution for that particular question directly. But indirectly, I'll try to help you out with that. Okay. So week 11 and question 12, sorry, quiz 12, first question. Is there any other concept that you want assignment or concept that you want me to discuss? Please let me know.
Sir, actually some basics. Sir, for example, if we are reversing a list, we are going for a traditional way. But in Python, it's showing that the two colon symbol minus one, it is giving directly the reversing of list. So like that, some simple terms we don't know.
Oh yeah, means we discussed it in one of the sessions, Leela, like reversing a list by splicing away. So yeah, but yeah, definitely I'll discuss that as well. So let me note that down. List reversing. Okay. Any other queries you have?
Sir, are there any websites where we can practice the kind of assignment quizzes they give us, like small uh, snippet of
Program?
program, then
Oh,
trying to
yes.
see what the
Yes.
output would be?
Yeah. Thank you for asking that question. So there are some websites. For example, there is a website called HackerRank, wherein you can go and, try out some basic programs in Python or any other programming language. So there are programs in general. There will be input given to you, output given to you, and then you like there will be certain test cases as you get in your uh, weekly assignments, programming assignments, and then you can try that out in any programming language of your choice. So you can write it in Python, C, C++, Java, whatever. The HackerRank is one such platform. Then there is Lead Code, which has a pretty good set of programming questions. So you can explore this as well. So this is being used by a lot of users or students for preparing for competitive programming. So you can look into this as well. There is another platform called Hacker Earth. So there are multiple platforms actually. So you can uh, look into that. Hacker Earth is one such. There is Code Forces as well. So yeah, there are multiple such platforms available, but you can definitely look into HackerRank and LeetCode for getting started.
Thank you, sir. So I was thinking of MCQ type
Oh,
outputs.
MCQ type, I
Yes,
see.
yes.
MCQ type, I'm not sure, but you can definitely look into some sources online, like uh, if you just search for MCQ questions on Python concepts, that will definitely point you out to multiple searches. Let me just quickly do a search. Yeah, so you will definitely get, but the only issue over here is that they may not be like relevant to the concepts that are supposed to be. Uh,
Exactly, sir.
yeah,
That was the problem I was having. Like, will it be the type of questions they give assignments
yeah.
for us?
So yeah, that's actually not. But you can definitely do one thing. You can try to find out MCQs on certain concepts, like for example, Python sets or Python NumPy library. So whatever is, so for example, NumPy quiz over here on W3 School. So you can try this out over here. So yeah, it will be useful for you. So if you go to W3 School quizzes, you'll find out quizzes on different concepts here, like and also you can find it out on other sources as well. So such topic specific MCQs, not Python in general. So if you want to have MCQs on Python dictionary, so yeah, you can find out over here and so on. So I hope that helps. But I will recommend like you can go through the material that we have discussed so far, and also W3 Schools is a pretty good resource when you can revise all the concepts. So this will give you an idea of uh, the basics of all the concepts involved which are needed for the course. But yeah, definitely there are other sources available which I'm not aware of, but you can look into it. Okay, so sorry. Are there any other queries that or concepts that you would like me to discuss? I'll try getting adding more MCQ questions from my side. I'll provide you with that so that you can go through them. Like so that should also be helpful. But just in case you need more questions, you can definitely look into some online resources. So I'll just compile all the MCQ questions that we have seen so far and also some other questions as well. and put them in one slide and then share that slide with you all. Okay. So yeah, thank you so much everyone for joining, and I look forward to seeing you in the last session uh, next week. So please keep checking your emails. It will probably be on Tuesday next week. Okay. Thank you everyone. I'll end the call now. I was late. Page and topic. Okay, Leela, I'll just upload this recording shortly. It's not that difficult. I have also given links over here. So if you just go to the slides, so there are some videos over here available on PageRank and Collat's conjecture. You can also look into them. You can even skip this particular lectures recording. You can look into these videos. These are pretty intuitive with some animations. So that will help you understand the algorithm in a better way. But yeah, definitely look into the session recording, the part where we discuss the algorithm in Python, like the Python code for the algorithm. So you can just uh, move to that particular part. I hope that will help. Yeah, thank you, Deepika, for the compliment. Yeah, that means a lot. Yeah, and thank you everyone for joining all these sessions so far. Like I have also learned a lot through all these sessions. So yeah, I look forward to seeing you all in the last session, uh, which is next week. So yeah, see you all. I'll end the call now. Thank you.